Hey, how are you? Today I'm going to show a very simple example on how to use a load balancer to distribute the load between all of the web servers that you have on your system. A load balancer, what it's going to do is to route all the requests between all of those servers that you created, and then those servers will have to work less. And that will be very good. That will be very healthy for your system because it will help the system achieve what is called high availability. And it's one of the techniques or one of the methods that you can use to achieve that. And why do you want a load balancer? Why do you want that on your system? Because in the case that you are not using a load balancer and the number of requests that you are receiving, number of requests that your web server, your backend web server is receiving is too much, and your server cannot handle that, then it will crash and your users won't be able to see the content because your server is down. And why does that happen? That happens because the CPU is the one that is in charge of handling all of these requests, and when all of those requests come, let's go back and tell you that it's not about the number of users, okay? It's not about the number of users that you have in your database, but the number of concurrent users, okay? And when they are making requests at the same time, your CPU won't be able to handle that number of processes at the same time. Well, it's not at the same time because it's concurrent, but what is going to happen is that a lot of requests will fail, other requests will take too long, and at the end, what can happen is that your server can die, okay? It can crash, and that's not what we want. We want your web server. We want to help the web server, okay? And this is going to be done by cloning your that web server and helping. You are going to give him some friends to help him, and the reverse proxy is the one that is going to be in charge of organizing all of that, okay? So here, this is what you usually use to start, and as you know, the user opens a TCP connection to your server, sends a request to this domain, and says, I want this. Your web server fetch that on the database, and that then returns that to your user, okay? That's what will happen. But if the number is too much, that is going to take longer, okay? And I already told you what can happen. So what you're going to do is that you're going to put a reverse proxy here in front of your web server. Here we use, just to tell you this, here we use concepts like in front of and behind of your web server. In this case, you're going to put this, your load balancer, and you're going to clone the web server. Let me show you so you see better. You put it here and you clone this. You clone your web server, and now you have a cluster of servers. And what is going to happen is that your user is no longer sending the request to your web server. Not anymore. Now the domain is going to be owned by the load balancer. The users don't know that because all of that is decoupled, and that's what you want. So the user sends the request to the load balancer, and the load balancer will, depending on different balancing algorithms, route this request to this web server, and this web server, this web server, and this web server, and of course it will always go to the database. Okay, I don't know, maybe depending. Well, now that I speak about the database, another practice that is used is to also put a load balancer in front of the database. It's one of the methods to achieve high availability on the database. It's not the only one. You can also use things like sharding, partition your database, but you do that depending on your requirements, depending on the different situations that you have. Okay. And the other thing that we do is that we know here you just have one load balancer, but usually what you will have is several load balancers, and one is going to act as the master load balancer, and the rest are going to be the backup load balancers. And this technique is called failover. What happens is that you are going to, if your load balancer cannot handle the number of requests, if your load balancer dies, the other load balancer is going to take control, okay? Because all of your load balancers communicate between each other using a connection, keep alive connection, and they will all the time will be speaking to each other. Hey, are you alive? Are you alive? Are you alive? If one load balancer doesn't respond, it's because he's dead. Okay, and now he's going to say, oh, okay, give me your IP, give me your. Now I'm going to take care of all of that, and that technique is known to as failover, but it's not for this case. It's, as I told you, it's a very simple case. Another thing I want to talk is about the algorithms that a load balancer uses to balance the load. Those are called balancing algorithms, and I know only 3 of them. The first algorithm that I know is round robin, which is the default algorithm that HAProxy uses. Round robin, what it does is that it toggles sequentially the request. Let me explain. A user makes a request, and then it does this, then this, then this, then send it here. Is what it's going to do. Okay, that's very simple. It's just changing the backends. The other algorithm is called maxconn, and what maxconn does is that it's going to see which is the web server that has the least TCP. Sorry, I go back. Sorry for my English. What it does is that it finds which is the web server that has the least open TCP connections. Okay, he has a counter when he stores that number, and the web server that has the least open TCP connections is the one that is more free. So you send that. Okay, you send that to that server, and that case can happen. That case can happen because maybe, depending on the case, the requests take too long to process, and that can happen. Maybe this web server has 200 open connections, and this one has only 50. So hey, let's throw this here. It's more free. And the other one that I know, but I only know that it exists, but I don't know how to implement that, it's called source, and it's depending on the source of the request. And what it does is that depending on the IP of the user, the load balancer is going to send the request to this server or this server. You usually do this when you have different servers located on different locations. And what you say is that what the HAProxy does is that it defines a set of rules. And when he says defines a range of IPs, and he says all the users that belong to Sweden will be working with the server that I have in Europe, okay? And all the users that which IPs belong to the United States will work with the server that I have in the United States. So that's the way that it works. I don't know how to do that. I don't know, but that's the way it works. And what I'm going to be teaching here is a layer 4 load balancer. Okay, a layer 4 load balancer is a layer that only works on the transport layer. In the OSI model, it works on the transport layer, which is the layer that only can see IPs and ports. The layer 4 won't be able to see the data that is coming. That's what the layer 7 does, because it implements the HTTP protocol. And in layer 7, what you do is that you can see the URL, you can see the headers, I don't know, and depending on all of that, you will send your request to the web server that you decide. You use that mostly on microservices, but in this case, that's not what we're doing. Okay, it is still monolith, but but trying to achieve high availability. Okay, this is not microservices. So this is layer 4. Okay, so I'm going to start explaining how this works, and I'm going to show you HAProxy first. I already did this. So HAProxy is a very lightweight proxy that was built using the C language, and the way it works is that it is going to load a file, a configuration file, and it's going to work. But let's see this configuration file. Okay, here this is the configuration file for HAProxy, and what it tells you is this. First, this is the maximum number of connections that HAProxy will be able to receive. Okay, by saying this, we tell HAProxy that we are using layer 4. Okay, if we say HTTP, then we will be telling HAProxy that we're using layer 7, and but this is not the case. This is for the timeouts. And now the most important sections of this is frontend and backend. And by frontend, you define how your proxy is going to communicate to your clusters. Okay. First, you say this, that you're going to be listening on this port. I can use any port that I want, but I'm going to use this. And I'm going to say that my set of backends, my cluster of backends is going to be named nodes, but I'm going to call anything going to call this like this if I want. Okay, and the first that I'm going to say is that these are going to be my 3 servers. Okay, these 3 servers are going to be the same. Okay, those are the same, and so these are the names that I'm going to put to each of one of those servers, and you know, the address and the port, the IP and the port of those servers. And by using check is I do this because I want to check all the time about the health of those servers, and if a server dies, if one of them dies, I want to be notified of this. Okay, that's why I do this. Okay, so the way to, okay, before doing this, let me show you the Express app that I have, my backend. And this is the backend that I have. It's a very simple one. Each request that I send, I'm always going to be receiving this. It's a useless app, but it's great for the example that I'm doing. Okay, if you can understand this, and let's run the apps. Okay, so you can see this. I'm going to run this on port 3000. Okay, I'm going to run another app on port 1001, and the other app on this port. Okay, I already did this, so this is what happens. This is my app. Okay, this is my app. This is my other app. Okay, and this is my other app. I have 3 apps. Okay, well, these apps are the same. These apps are the same. Okay, they do the same. I use change these numbers so you can see, but at the end the apps do the same. So now I'm going to put HAProxy to work. Okay, the way to do this is by saying HAProxy, the file that I want, and TCP is the file that I want. Okay, I have no problems, so everything is okay. And as you know, I had HAProxy working on the port 888, I think. Okay, and as you see, HAProxy routed my my traffic to this port. Okay, to this app, which is in the port 3000. Okay, that's what happened here. That's what HAProxy did. So if I do another request, now it's going to route my traffic to the other app. Okay, that's what is happening. That's what is happening. Okay, that's what happens. Now let's check this. I'm going to kill one app. I'm going to kill this app. Okay, this app is down. Okay, I kill this app. Check it. This app is down. But HAProxy tells me that this app is down. That server one is down. Okay, because I tell him to inform me this, and when I do a request, he's not going to. This is another user, okay? it's not going to send me anything to that to the port 3000. Okay, very smart. So now I'm going to open this again. And now I'm going to okay. Okay. And now I received, I have this app working again. And you see, everything is great again. So, but this happened because I told HAProxy to give me those reports. But if I don't tell HAProxy to give me those reports, if I remove this, it's not going to complain. Okay, and that's bad because I won't know what is going on. Okay, so that's the way HAProxy works. I hope you learn about this, and